Okay, good evening. Welcome to Math for Kids number 29. Today we got two problems out of the Olympiad book. And, well, you ready?
Yeah.
This is actually a number 5 problem, which is usually means they're pretty hard. But actually, I don't think this one's that hard once you understand it. So we got to take our time and make sure we really understand the problem, okay? 20 pennies are divided into 3 piles, with each pile having a different amount of pennies. What is the smallest amount of pennies that in the largest pile? So, I didn't write this very well. I never write these very well. What is the smallest amount of pennies that the largest pile can have? So we got 20 piles, 20 pennies into 3 piles, and we're trying to figure out the smallest amount that the largest pile could have if each pile has a different amount of pennies. So, for example, could the largest pile have 1 penny?
No.
Why not?
Because then the others would have to be. Because then the others are going to be smaller than that.
Yeah, they're going to be smaller.
Half penny.
Yeah.
Third a penny.
Okay. So what else? So how else do you want to think about this?
We know it can't be 1.
You know it can't be 1.
Actually, it can't be 2.
Can't be 2.
We could just check all the way up to 20 and find some that work.
We could, or we could think a little bit about it.
Yeah. So
Yeah.
thinking,
sometimes helps. Not always,
but maybe.
but sometimes.
Yeah.
Okay. Well, check. Keep checking. Maybe checking is a good way to do it. Could it be 3? Could the largest pile have 3?
No.
Why not?
The reason, because it wouldn't add up to 20.
What would it be if the largest
3,
pile
2,
had
and 1.
3, 2, and 1? So that wouldn't work.
Well, and then it would be 4, 3, 2.
Does that work?
No. And then 5, 4, 3. No, that still doesn't work. 6, 5, 4. It's 11 plus 4, that's 15. That still doesn't work.
Still doesn't work. Okay.
And then, so I was on 6?
Yeah.
7.
7.
So 7, 6, 5. That's 13 plus 1, that's 18.
Okay, that doesn't work.
How about, I just did 8.
You just did 7.
Oh, so 8, 7, 6.
Okay. What's that?
That's 15 plus 6. That's 15 plus 6 is 21.
Okay. So, does that work?
No, it's
Why not?
over 20.
It's over 20, but it's not equal to 20. So why don't you write that down?
The 8.
876. Just step out of the way of the camera when you're writing it. Remember, come over towards me. 876. Okay, so that doesn't work. Why not? All the other ones didn't work because you didn't have all the pennies. But here, why doesn't this one work?
You have too many pennies.
Too many pennies.
That's confusing.
Is it?
Because 7, 6, 5, that was too low.
Looks like you wrote 769.
7, 6.
765 was too low.
But
So 765 only used 18 pennies, so we knew that couldn't be enough. 876 used 21 pennies though, so I wonder if there's a way we could do something here.
But we can't use fractions.
We can't use fractions, and we sure can't.
Well, we can't. Well, do they have to be like consecutive?
Well, what does the problem say?
Because they have a different amount. It doesn't say anything about
It
consecutive.
doesn't say anything about consecutive.
I have an idea now.
Okay, what is it?
Oh, done. Mine didn't work. I think of changing the 8 to a 7, but it said having a different amount.
Yeah, they have to have a different amount. So if you change the 8 to a 7, then you're going to have 776. Keep thinking of other
That is
ideas.
20 though.
That is 20. That's nice. The nice thing is we have more than 20 here. So how are we going to make that equal 20? Here, stand over there.
Oh, I have an idea.
Okay, what
How
is your
about
idea?
875?
Ooh, 875. So we want to take 1 penny away, right?
Yeah, so we
So
can't
if
take it from 8.
If we take it from the 8, we oh shoot, it's 776. If we take it from the 7, it's 866. Darn. But if we take it from the 6,
it's 875.
it's 875. So now the only thing, so what's the smallest amount of pennies that the largest pile can have? At least we think right now.
We think it's 8.
We think it's 8, okay? Now we just have to make sure you can't fiddle around with 7 and make it work. Well, if the largest pile had 7 pennies with no restrictions at all,
yeah,
you could do 777 and still get to 21. Can you take 1 penny away from that and make it work?
Yeah.
With no piles having the same amount of pennies?
Yeah, 776.
776, so no piles have the same amount of pennies?
Well, no piles. Actually, the piles have the same amount.
Yeah, actually the piles have the same amount of pennies. The problem is when you only take 1 penny away from 777, what happens?
You're gonna get 2 6s or 2
Stand over there.
7s.
Good. You're gonna get 2 6. You're gonna get no. You're not gonna get 2 6s or 2 7s. You're gonna get 2 7s.
Right.
So we just tried it out. So the one way to figure this out is 20 divided by 3
You can't divide 20 by 3.
is a little bit less than 7, right? It's
Yeah.
6 remainder 2. So we know 7 would be a good starting place because you know you're gonna have to have something bigger than 7 or bigger. So 777 would work, except what's the problem with 777?
We can't. We have to have the different piles.
Yeah, you have to have different piles, so now you have to go up to 8. And 876 was a good try, except what was the problem with 876?
Too big.
Too big. So how did you make it smaller?
We subtracted.
So you took away 1 from the 6 and made it 875. Okay, great job, sweetie. Ready for the next problem?
Yep.
All right, here we go. Here's the second problem, and then we'll be done.
Yeah.
A rectangle has a perimeter of 30, and all the sides have integer lengths. What are all of the rectangles that have this property? Okay, do you remember what perimeter means?
Yeah.
What does it mean?
So like,
Okay, step around. It's over here.
here's a
Okay.
rectangle.
Okay, here's the rectangle. And what does it mean to be a rectangle?
Well, the two sides that are facing horizontally, top and bottom are the same, and the two sides that are facing vertically.
Okay, so what should you call those sides? Maybe would be a good thing to call them.
X.
X, and Y, Y. Okay, and what do we know about X and Y here? Oops.
X.
No. Okay, so it's what are your sides?
Whoopsie.
Whoopsie. Grab an eraser.
Evie, so. Oops, then let's keep this here.
Okay, good idea. All right.
So, well,
What do we know from the problem?
we know that. Oh, is that what we
Yeah,
did?
step over there that way.
2x plus 2y equals 30.
Okay, so 2x plus 2y equals 30 because the perimeter, let me just draw the perimeter. The perimeter is once around. So it's x plus y plus x plus y, which is 2x plus 2y, and that equals 30. Okay?
And all the sides have integer lengths.
All the sides have integer lengths. Okay?
I bet a lot of rectangles have this property.
I bet a lot of them do. So is there something we can do to make this a little simpler? 2x plus 2y
30
equals,
what?
let's say feet.
It's a big rectangle.
It is a big rectangle. Well, let's see. So 2x plus 2y equals 30. What can we do now that's to make this even a little easier?
2x plus 2y. Well, look at that. X plus y equals 15.
Okay, great. X plus y equals 15. Now this should get interesting.
Yeah.
So we have to figure out all the rectangles that have this property. All right, we're gonna make a chart. Let me see if that's where the bottom of the camera is. I can even go a little bit lower, but that should be enough for our chart. So let's do it like this. So we gotta have x plus y equals 15. So let's do x and y. Okay. So what's the lowest value x could be?
X could be 0.
Oh, would that be a rectangle?
No.
Wouldn't be a rectangle.
X could be 1.
1? Okay, what would y be?
14.
Okay.
X could be 2. No, I gotta move to this side.
Here, use this. Use the purple.
Okay, there's a cat.
Okay. X could be 2. What would Y be?
Y would be 13.
Okay. X could be 3.
12.
There.
Yeah, that's better.
Okay. Go. So if X is 1, what's Y?
14.
14. 2.
2. 13. 3, 12.
Stand over more than
4.
4 is
11. 5 and 10. 6 and 9.
okay.
7 and 8.
7 and 8. Okay.
I'll just go a little harder. No, you can't.
Why not?
It could be 8 and 7. But 8 and 7 is the same as that.
Right. See, one rectangle has a short side that way and a long side this way, so this would be 7 and that would be 8. And the other one has a little bit longer side this way and a shorter side this way, so that would be 8 and 7.
Yeah.
Those are the same rectangle.
Yeah.
Okay. So how many rectangles had our property? How many different rectangles had our property? Their perimeters were 30 and their side lengths were integers.
7.
7. Let's just check one of them to make sure.
Okay, let's check.
5 and 10. Okay, what's the perimeter of a rectangle that has sides of 5 and 10? You want to draw it? You want to draw 5 and 10 here instead of 7 and 8? Okay, don't block the camera when you draw. Okay, is the perimeter of that 30?
Yeah.
Okay, great job. Alright, so the homework for today, or for tomorrow I guess, is Olympiad 13, problem number 5, and Olympiad 14,
Number 1.
problem number 1. So Olympiad 13, problem number 5, and Olympiad 14, problem number 1.
Yeah.
Alright, good job. Good job tonight, honey.